So I'm going to rewrite the equation. This is called, T1. This is called the combined gas law. Now many people will teach you some other laws before teaching you this one, but really this is the only one you need, okay? And I'm going to show you what I mean here. So let's say, for example, we're going to start off with what are called Boyles Law problems, okay? And what Boyle said was, before they came up and put all of this together, Boyle noticed that in the other video, or this little video I'm going to show you, he shows that just this part, I get my numbers straight, that as the pressure goes up, as my pressure increases, the volume over here has to decrease. So as my pressure increases, volume decreases. And if the pressure decreases, my volume is going to increase. This one I like to think of as the balloon, okay? The balloon law. If I have a balloon and I squeeze on it, what's going to happen? You're going to squeeze the volume down. If I can pull out the balloon, okay? If I change the volume, what happens to the pressure inside? It has to drop. Okay? So, but to make things simple for us, we're going to solve these problems all together. So let's say we're looking at a problem, and it says you have a pressure of 1.5 atmospheres, and you have a volume of 0.05 liters, and the pressure changes. So it's changing. You got to be careful as you read these word problems which condition you're talking about. It changes to 700 millimeters of mercury, and now we are wondering, what is my new volume? Now notice, what did it leave out? It left out these bottom ones, okay? So, first we're going to continue our guess method. Our givens, next step of our givens is conversions. Remember that? Do we have to convert anything? Atmospheres? No. Liters? No. Millimeters of mercury? Yes. We write our words first. Millimeters of mercury to atmospheres. 760 and 1. We plug that in our calculator. 700 divide 760. We get 0.92 atmospheres. And we have our volume, which we're looking for. The next step, so we've got our given. Our unknown is our volume. Our equation is actually going to be this one. And I'm going to run out of room here on the board, so I'm going to write it up here to make sure you can see it. So my equation is P1V1 over N1T1, P2V2 over N2T2. But if these don't change, if it doesn't talk about them, I can do you have two options. One of them is, because the next step after the equation is to substitute. So for my pressure, I have 1.5, P1. For my volume, I have 0.05. I could put a 1 in for N and a 1 in for T, and my pressure would be 0.92 times V2 divided by N2. Because it's not changing, I can put the 1s in. But what does that really wind up being? It winds up being as if they were never there. Okay? And you just use the top part. You just use the ones you have. Now, with that said, I will make mistakes if I start doing it that way. So what I like to do for myself is I will go ahead and put in N1. It does not talk about moles, so my N has to have a value of 1. And temperature is not mentioned, so it has to have a value of 1. Okay? And if you really want me to go into some more explanation of how that might actually work out for you, but N1 and T1, N2, T2. Now, if you get it, if you don't have it, you don't need it, cross it out. You just use what you do have. Okay? So, let's go ahead and finish our calculation. So 1.5 times 0.05 equals 0.075 equals 0.92 times V2. Now what do I do? 0.92 on both sides. Point 0.92 and 0.92 cancels to 1. V2 times 1 equals V2, which equals 0.08. 0.08 liters. Okay? 0.08 liters is my new volume. Does that check? My pressure went from 1.5 to 0.92, so it dropped. So my volume better increase, and it does. It increases. That's Boyles Law. You might even write a little P goes up, volume goes down. They're opposites of each other. Okay?